Hello there all, welcome to eosacro. This video is a part 2 of the tracking tutorial in Nuke. In the part 1 we have already seen how to do some auto tracking, user tracking, the different options involved, and how to finalize on our track. In this video we are going to do some face tracking by generating a few masks, and then we are going to generate some point clouds, a mesh, project some textures on that mesh, and finalize our composite. So let's get started. Now before we actually get started with tracking, let's observe this footage for a while and see exactly what's going on. We have here a HD 1080p footage and it's about 231 frames long. Here I have my friend Rahul, and he's just rotating his head a bit, and the camera totally stays still the whole time. Also, a great thanks to Rahul for letting me borrow his face for doing all of these things, and as you can observe I have even marked his face, so thanks a lot and sorry again. Okay, coming back to this, this time I want to go ahead and track his face, but I don't really want to be tracking the background at all. So let me show you what I mean by that. I'll go ahead and take in a camera tracker. With the camera tracker connected, if I turn on my preview features, you should be able to see that the features are selected even in the background, and as you know, there is nothing in the background and it's not actually moving according to his face, so therefore it's going to give me a bad solve if I try to keep these background points. So what I actually want to do is use this mask feature in the camera tracker, and to use this I need a matte. So let's go ahead and create a matte out of the footage so that I only get his face to be tracked and nothing outside. So I'm keeping the camera tracker aside for now. I'm going to bring in a simple keyer node. So let's bring in a keyer. So this is a simple keyer and it gives you the output in the alpha channel. So let's go into the alpha channel to see exactly what we have for now. So this is a simple Luma key which it has done right now, but what I actually want is a color key. So let's see the different colors for once. The red color, as you can see, the hairs are completely black, and if I want to matte out the hair, this is the best key to pull from. If I go to the green, you can see the skin and hairs are pretty dark, the background is pretty white, so this is quite useful if I want to key out his whole head and remove the background. If I come to blue instead, you can see it's even more darker. His skin and hairs have almost the same shade and the background is even more white. But also one more thing to note here is that this shading on the skin, this specular highlights on the skin, is much more pronounced, and the reason I'm concentrating on that is that if you see on the 0th frame, you can see this specular highlight right in front of his nose, whereas if I come forward, because his head has rotated, you can see that this highlight has now moved to the side, and Nuke is not as smart to recognize that this is a specular highlight moving. It would assume it's an object moving and it might track it onto the side, and this will result in bad tracks. So I actually want to make sure that those are removed also. So what I'm going to do is set this operation to a blue keyer. I'll go to the alpha channel, so you can see I have the same result in the alpha channel as I have in my blue, and in the alpha channel I'm going to start keying. So let's go ahead and start the simple key. Okay, so as you can see, it was a very quick key. I'll just clamp in the gamma to make sure I don't have any unnecessary holes in the matte. Okay, so as you can see, I have a very simple key. I have this entire background black, and whatever I have in the foreground is completely white with a few transition areas here where the specular highlight exists. So that's pretty much it. That's all I wanted from the key. Now I have an alpha channel which is going to give me all these details. Now apart from that, there is another problem. So let me go to the camera tracker again, and if I look at the preview, I'll turn this exposure down. I'll put in this mask as a source alpha inverted. I'll tell you why it has to be an inverted alpha in a second, but before that let's observe this. You can see that the auto tracks actually exist at the edge of the head, and this is because the alpha channel actually exists till this edge and it's making use of all the alpha. But really I don't really want the edges to be tracked because they are going to give me this parallax motion which is almost straight towards the camera, and it would give a lot of jitter. So therefore I want to clamp in the alpha. I want to pull it inside a bit so that all the tracks which are at the edge are pulled in a bit. So to do this, what I'm going to do is after the keyer is done, I'm going to add in a simple erode. So let's go add in this erode filter. Going into this, I'll go to the alpha channel, and here I can actually start eroding this. So as you can see, it pulls things inside. So I'm just pulling it a little bit in, and I'll filter it using Gaussian so that it's quite faded out, or quadratic. Okay, as you can see, edges have been removed a bit. Also, it's not that great right now, so I think I'm going to stick with a simple non-filtered version. So let me remove this erode. I'll put in a different one. Erode fast. Okay, that also gives me similar results. So I'm going to remove that. I'm just using whatever gives me the best result. Okay, this is giving me better results, I believe. So I'll just go ahead and use this. Okay, pretty cool. So I have this alpha channel which is created now, and as you can see, this is what I had before. I've just eaten in the edge a little bit so that it doesn't give me the exact edge. So now coming back to the tracker, you should be able to see that the edges are no longer there, and if I remove this erode, you can see the edges exist once more. The trackers exist at the edges once more. So enabling and disabling it. So just bringing in the trackers, that's it. Now I've done the simple operation. Now the next thing is setting the default parameters for the whole track. So first off, I want to talk about this mask input. As you know, we have just edited the alpha. The inside is white and the outside is black. By default, when you're trying to track, the alpha is set to objects which do not have to be tracked. Basically, it's a rotor shape which has come in about a character moving or some objects in the foreground which had to be garbage matted out. So therefore, if you set this to source alpha, it basically means do not track the white, only track the black. So by default, the camera tracker is going to work with the black values rather than white. So that's why I've set this to source alpha inverted, so it's working with the white values instead. Now I've set that one in. Once that is done, I'm going into the tracking options and I'm going to start increasing these values a bit. We have already discussed what these do, so I'm not going too deep into them. So I'm increasing the number of track points, so I have a lot of track points covering his whole face. And also I'm going to increase the number of detection threshold so that tracks are distributed on proper points. I'm going to decrease the feature separation so that if the features exist, I want it to stick to it properly. I don't want them to be too far apart. So let's say about 8 there. And I want the minimum track length to be about 40 because there is a long frame and tracks would last about 40 frames quite easily without problem. So I've said that. I'm going to increase track consistency and increase track threshold. Okay, so that is done here. Also, if I want, I can refine edge feature location so that the tracks are only on the corners, but right now not really necessary. Apart from this, obviously I need to set in some camera properties, so let me go ahead and set these default values as before. So it's the same 28 focal length on this footage, it's 22.3 and 14.9. Okay, that is done. I want to increase the smoothness to 0.1 for the camera solve, and also I want it to be high detail solve with 3 frame initialization. Okay, that is done. Next, I don't really want any lens distortion parameters added because it's a rotation of the head and it would give me very bad results with lens distortion. If it was a straight line or something straight in the footage which was rotating, it would have given me a better result. So this one I'm not going to touch. Now with this thing done, all I have to do is track and solve the camera. So let me go ahead and track features. As you can see, it's going to take a bit of time to track the whole thing. So I'm going to pause the video for now so that it tracks the whole footage forward and then once backward and stops. So after it's done, we only have to solve for the camera. So it has just finished tracking, and as you can see, the track is pretty neat. All the tracks are going in proper directions. It took about 2 minutes to finish this whole track. So now that this is done, I'm going to go ahead and hit solve. But before that, I just wanted to observe that wherever the specular highlights are there on the skin, you can see that the tracks over there are very less. So therefore, most of the specular highlight is being ignored. So this basically means all of my tracks are pretty neat, and it's going to give me a very good result. And this is exactly what you had to plan every time you're going to track something, so that you get good results without having to solve them again and again. So now with this done, I'm just going to hit solve camera and wait till it's done, and I'll get back to you. So it took about 5 to 10 seconds to just solve the camera, and as you can see, it's a pretty neat result. There are only a few tracking errors over here and there. What I'm going to do is still go into refine. As you can see, solve error is 1.5. This basically means there is about 1.5 pixel slip throughout the whole thing. So I'm just going to go ahead and decrease the error values over here so that I get less number of error tracks. Okay, with this decreased, I'll go recalculate the solve, and let's see how much error I have now. As you can see, it's only 1 pixel error, and that's awesome. So I'm just going to go ahead, delete rejected points and delete unsolved points. So finally, all I have to do is go ahead, solve it once more just to make sure it's perfect. So let me go ahead, hit solve. And it's done, and as you can see, the solve error is only 1 pixel, and that's perfect. So there is only a maximum of 1 pixel slip. Now that all of this is done, the next step is actually generating the point cloud itself. Previously, when I created this tracker, well, you remember that I was actually generating the whole scene. But this time, to actually create the point cloud, I only need to make use of the camera. So all I'm going to do is tell create camera, and I get the single 3D camera node, which has all the camera animation required for the whole scene. So I don't really care about anything else right now. So let me go ahead to the 3D camera and see what we have. First thing I observe is that I already have the simple point cloud, but it's not really that great. What I want is a bigger scene, or easier scene to work with. As you can observe, if I select the camera, the handles itself are as big as a whole face. So for this reason, I'll go into the scene and increase the uniform scale so that the object is larger. So let me go ahead and increase it to about 40. Okay, so now I have a larger face so that I can work with it easily. As you can observe, I've not actually set the proper scale of this scene because it's not really that necessary. So as you can see, I have the camera and the face, and the camera is moving. Let me go ahead to the 3D drop down into geometry. I'm going to make use of the point cloud generator, right? So opening this up, you can see it has several inputs. Basically, we have the camera, which is actually moving, or the animated camera. Then we have the source, or the source footage, and if we have any masks which we want to make use of. Basically, our source footage itself has the mask we want to make use of, so I'm going to put that in there. So let's take the point cloud generator. I'll connect the source into the actual footage which is coming in. I'll take the camera, connect it to the camera footage there. And now in the point cloud generator, I have a couple of options to take care of. First off, I have the ignore mask. Similar to the camera tracker, I have to set this exactly to the same source alpha inverted, so that it's going to ignore all the other values or pixels from here and there which are unnecessary. Now, once that is done, the next step is actually to analyze the sequence. Basically, what analyze sequence does is it looks at the camera move and how the speed is, or how much parallax is going to be there in each move, and it is going to set keyframes on every one of those frames which it has to calculate. So we can just go ahead and click analyze sequence, and it's going to start moving and play through the whole thing and start putting in keyframes everywhere. So let it go ahead and finish this, and I'll get back. It took less than a minute to do the whole thing, and as you can see, a lot of keyframes have been added here at the bottom. So all I have to do now is that once this operation is done, I'm going to go into my actual footage. I'm going to look at this and see exactly what I'm going to do with it. As you know, I want to put in some scratches on his face exactly here on this side. So I'm going to make sure the camera is looking exactly at that part of the face. And then I'm going to tell Nuke that it has to track points. So I'm going to just click track points, and it's going to ask me how many number of frames it has to track. So I'm going to tell it has to track all the frames to get the points. With that, I'll hit OK. Even though I have selected all the frames, it's all going to make use of all the frame data for only a single frame and calculate the points. As you can see, it's going to take a little while to calculate the single frame. It's showing me about 4 minutes. So let me go ahead, pause the video, and get back to you once the point cloud is generated. Okay, so the point cloud generation took somewhere about 5 to 6 minutes. So now I have this node ready, and if I go into the 3D view, you should be able to see that you have a pretty neat approximation of the actual face of our actor himself. So once we have this face, first thing we have to do is go ahead and analyze it and see exactly how many mistakes there are. So let's see what I mean by that. If I come to his forehead, you can see that there are a few of these bumps on his forehead. It's not actually flat like it's supposed to, like in the footage. The reason for this is because of the specular highlights that we had. So therefore we are going to go ahead and try to get rid of these kinds of problems we have. Also, if you observe, we can see that there is kind of a empty space around each one of these markers. That is same way related to how they did the tracker separation in the camera tracker node. So similar thing has happened even here with the point cloud. So anyway, that doesn't matter. Well, now once we have all these points generated in the point cloud, what I'm going to do is go ahead and just remove all of the points which are unnecessary, because there are a lot of points here which are quite bad. Like you can see, there is a lot of these points which are white in color, which is a transition color between the hair and the background. So what I'm going to do is come here to display rejected points and start increasing the angle threshold. As I increase this value, you can see a lot of these points turn red. What I want to do is actually delete these points, but if I do that, all of the points I already have would be deleted too. So what I'll do is go ahead, copy this node and have a copy pasted here on the side, and because it's the size of the amount of detail in there, it will take a while. Now once I have a copy of it done, I can easily go ahead and start deleting unnecessary values. So I've gone ahead and increased the angle threshold. I'll also go ahead and increase the density threshold to make sure most of the points which are unnecessary will be deleted. With these two values set, I'll go ahead and tell delete rejected points. When I click that, it should take a second and delete most of the points from the whole view. And as you can see, now the forehead looks a lot better. It's not perfect yet, but it's a lot better than it was before. And also I can go ahead and start generating a mesh out of this forehead. So now what I actually want to do is apply a mesh, apply a texture on this part of his head. So therefore I need to generate a mesh only on that region. So to do that, I need to select these points to be able to create a mesh out of them. So to do the selection, for what I have to do is in the viewer, I'll go to the selection drop down and go to vertex selection. So when I'm in the vertex selection, you can see all these points are now visible as dots. I can change the point size here so that I can see the dots better. What I'm going to do is only select the portion of his head which is necessary for creating the texture, and a bit more extra to just make sure that I know where I'm working. So using the shift key on my keyboard, I'm going to start making a selection here. I'm going to select all the points I think are necessary. So I'm just selecting all the points which would help me create the scar. So just take some time, be slow with this, because this is one of the most easiest and most useful steps right now. So let me go ahead and select a few of these there. Okay. So I've pretty much selected all the points that I need. I have a few extra than I actually needed, so that if there is any issue, I have some points to back up. Okay, so with these selections done, what I'm going to do is switch over to the groups node here, the groups tab here in the point cloud generator node, and here I'm going to tell create group. Basically all the points I've just selected go into a new group. So clicking on that, you should get a new group with a new color for all the points you have selected. Make sure that there are no holes in whatever selections you have made. So once you have this new group, you can easily go ahead and select or create a mesh out of it. The way you do that is tell bake selected groups to mesh. By default, most of the times when you do that, you end up with a mesh which is very jagged and rough. So to avoid that, what I'll do is set samples to 2 or maybe 3 to make sure the mesh is quite smooth. So by setting samples to 3, I'll select the group and tell bake selected groups to mesh. It'll take a minute. It's going to go ahead and use the mesh generator algorithm and go ahead and give you a new node called the baked mesh group. And I can go ahead, put that into my viewer. I close this point cloud generator node now. As you can see, it has generated a brand new mesh for you. But because it does not really have any normals or any texture applied, or it doesn't have any UVs to begin with, it's always going to be flat shaded. So just to make sure I can understand what I'm looking at, I'm going to just go ahead and project a texture on top of this. So I'm going to bring in the project 3D node. And with this, I'll connect the actual camera which I have just created, the camera which I'm making use of. And also I'm going to connect the original footage which I have before the keying part, because I don't want any alpha channel to ruin whatever I'm doing. So I have this project 3D node which I have connected now, and as you can see, it's a pretty neat mesh. It's giving me quite nice forehead detail there, and if I put anything on top of this mesh right now, it'll be there. It'll match up perfectly along with whatever I have in the final scene. So this was about generating the mesh using the point cloud and tracking the forehead. I hope you understood this part. I'll go ahead in the next section and show you how exactly we can go about texturing this mesh even though it does not have any UVs yet. So I'll see you in the next section. So now we are basically almost at the final stages of this tutorial. What we are going to do now is first apply a simple checkerboard onto this mesh to just check whether or not this mesh is fitting in properly with the actual footage or if this is going to slip. So to do this, we are going to go ahead and create a new camera from which we are going to project a texture onto this mesh. So let's go ahead and do that now. I'll go ahead and create a new camera. And with this camera, I'm just going to go ahead, set this as a new camera on the projection node. And with that set, I'll go ahead, create a new texture for projection, and that's going to be a simple checkerboard for now. I'll connect that in as the texture. Okay, so now as you can see, I have a simple texture applied on top of it, and it's being projected using this camera. What I'll do now is go into the camera view. I'll control click on the camera lock so that it's locked in, and now if I move the camera, you can see it's actually changing the texture on the object directly. So now if I zoom in too much, you can see the texture gets cut. So that's basically how much freedom I have for this texturing right now. So first thing I want to do is rotate the camera so that it's properly aligned. So I'll control shift rotate so it's aligned properly, so that I'm making use of as much of the texture as possible. Okay, so my basic camera texture has been applied now. I'll just go disconnect the camera. Okay, so I have this. One thing I notice is that the camera is too much from the front. I want it coming up a bit from the side there, so let me go back in. I'll rotate this and bring it back into view so that I'm looking at the whole mesh a little bit from the side now. Okay, cool. So I have this texture applied. Also this time the camera is looking at it from the down portion. I want it to be on the top, so again I'll go lock onto the view and make sure I'm moving upwards. So that's pretty much done. I have this checkerboard texture applied, a basic texture, and now I'm going to go and apply a Scanline render node, combine this checkerboard texture on top of the original footage and see whether if it slips. So to do all this, let me go ahead, put all of these nodes on this side. I'll create simple Scanline render. Okay, so now what are the main things I want? Obviously the 3D scene, I want the object to be the baked mesh which is coming in. I don't need to create an actual scene for any of this. Next, I want the actual render to be from the original tracked camera which we have. So let me select that. And now if I go into the viewer and check the result I have, you should be able to see that I have this checkerboard texture coming in exactly where the forehead's supposed to be. So we have that, and if I connect the BG, you should be able to see that this forehead is aligned exactly in the same position as a checkerboard. But obviously I don't actually want the original footage in the background. I actually want it to be blank. I want it to be flat blank. So I'll go ahead, create a constant, and I'm connecting this into the background. And I'm going to set the constant format to be the same size as the original footage, which is the HD 1080p. So that gives me there. Now once I have this done, I want the original footage to be composited along with this. So I want this basically added on top of the original. So I'll take the merge node. So the original footage is going to be my background. So I'll connect that to the B pipe. And the new rendered output is going to be the A pipe. So I'll connect that there. Now looking at this result, you should be able to see that the checkerboard is actually on top of the forehead. I'll go ahead, take down the mix value so I can just see what's happening. I'll set this to overlay just so I can see whether if the checkerboard is slipping. And let me go ahead, I'll take a proxy flipbook of this and see and get back to you in a second. So to take the flipbook, I'll select the node, I'll go to render, flipbook selected, I'll turn on use proxy, and I'll go ahead, flipbook this. So now I have my flipbook ready, and when I play this through, you can see that there is no slip which can easily be recognized. There is not a lot of it, and the checkerboard is sticking quite well with the actual footage that we have. Also, once the motion blur is added in, it'll be even harder to distinguish between what has been blended in from the 3D part. So we have this checkerboard which is fitting in properly. Now all we have to do is texture whatever we want on top of the mesh and apply it on the actual actor. So let's go ahead and see exactly how that can be accomplished. Now here within Nuke, all I have done is apply the checkerboard on top of the mesh, and this is the result we have right now. What we actually want to do now is go ahead and apply whatever texture we want onto the Scanline renderer here, and that texture will be automatically applied on top of our original mesh. Only thing I want to take care of is that in the merge node, I want to make sure I'm using alpha for masking so that the object is only making use of its alpha channel for compositing, and it's not being bled into other parts of the mesh where the 3D object does not exist. Also, another thing to note, in the Scanline renderer, I've turned off all kinds of motion vector renders, I've turned off motion blur, I've even gone ahead and turned off anti-aliasing. So if you want to get better quality results, you can go ahead and turn on anti-aliasing. So we'll look at all of that later. Now what I want to do is just go ahead, increase the amount of space I have here to apply whatever texture I want. Also, if I go ahead and look at the baked mesh group right now, I'll not be able to see any results. Also, if I go to the checkerboard, you can see it just looks normal. What I want is the actual 3D look as to what this would look like once it's projected onto the mesh. To be able to look at that, what I'm going to do is create a new Scanline renderer, and this time I'm going to again re-render the object, but this time I'm going to make use of the static projection cam I have to finally render it out. Now with this setup, if I go ahead, look at the Scanline render. Let me move the checkerboard away. You should be able to see exactly the 3D object with this patch applied, but from the projection cam. So this is exactly the same thing as a checkerboard, but only it's cut out to show the object itself. So once I have this, what I will do is put my checkerboard as my first view and my Scanline render as a second view. And with this set, I can go ahead, put it on over, and now I should be able to tweak this and have a look at exactly what is happening. Okay, so now once this is done, I can take in roto nodes, I can start painting in whatever I want and see exactly what result I will get even before it happens. Also, this is the perfect time to make use of multiple viewers in Nuke to see what result we are going to get finally once all of our compositing is done. So let me just make in some room here, and I'm going to go ahead, split this section here, and I'm going to add in a new viewer. So this is the place where I will be working with the texture. So let me go ahead, close off all of these sections which I don't really need. And with my second viewer here, I'm going to look at the final result. So whatever changes I do here should be visible over here directly, so I know exactly where I'm working. So now with this thing done, I can come here to the checkerboard, remove this and start applying any texture I want. So let me go ahead, I'll start tweaking the texture. I'm just going to procedurally create some scar tissues on him. I'm not going to waste a lot of time trying to show you how I'm doing it, but I will explain how I did it. So let me come back in a few minutes. So now I have gone ahead and added in all of the scar tissue which I wanted. And let me just go ahead and show you what kind of things I have changed here. First off, the camera, the projection camera which I have set up, I've gone ahead and added an axis which is going to control this camera so that this axis can sit exactly where the actual object sits, right behind the object, so that I can control the projection easily. Like let's say if you wanted to animate it like sliding on the mesh or something as such. So this axis is basically controlling the camera this time. I've gone ahead and blackened out this nodes here which are not actually used for rendering purposes. And all of the texturing which I've done is basically over here on this side. So let's go through and see exactly what's happening here. So first off, I've started with this basic constant. There is absolutely no particulars for this. I've gone ahead and taken a simple constant of 2K texture. You can go ahead and choose any size that you want. On this, I've gone ahead and created some noise. This is basically going to create some variation so that it does not look very flat. So with this, I've added another layer of noise, and this is basically adding a bit more blue color because when you have some kind of bruising, you usually have blue colors on your skin. So I've gone ahead and added that. Along with the noise, you have to take care of the kind of alpha channel I'm using here, because every time I'm doing something, I'm making sure the alpha has some variations alongside it. With that, I went ahead and created this simple roto where I've just created these simple Bezier splines where they go about and create these scars and also bruising surrounding these scars. So it just goes ahead and creates these variations and adds in some extra detail. So as you can see, because I have added in some feather, it looks like it's actually cut. So with this one done, I also went ahead and use the same roto paint node over here and got this different result. Well, I'm basically working with the alpha channel over here this time, so it's just working with the alpha channel to give me this pure sharp cuts like masks. I'm creating some noise using these masks inside, so it's giving me this black solid like crusted blood kind of an effect inside. So with this one done, I went ahead and again graded the alpha here. So I'm just changing the alpha once more, where I'm just clamping all the black values. With that, I went ahead, added an emboss. So you can see what kind of an effect this emboss produces. and once that emboss is produced, I went ahead and added it back on top of the original. So what I previously had was this scar tissue, and with the emboss applied, it gives me so much detail, and as you can see, the scar actually looks like it now has some depth. So once I added that in, I went ahead and created a simple roto shape, so basically which goes across here and produces this alpha mask. This is basically so that this is basically created so that I don't have these harsh edges of the mesh, and it goes across as smooth as possible, trying to give me a very smooth blend. So you can go about and create this as smooth as possible. So I just created this one, and then finally I went ahead and pre-multiplied all of this so that I only have this amount of scar tissue visible. Now finally what I've done is gone ahead and rendered this. As you can see, after rendering, I only have this very simple. Okay, let me just increase the gamma here so you can see. I have this very simple scar tissue which is coming across over here. But finally, during render, I realized that even though it has a lot of color, the amount of saturation it has is not enough. So I added in some color correction to increase the saturation of all these nodes. And I've added in some vector blur just so to get some small motion blur inside it so it does not look out of place. I've gone ahead and added in the motion vector values. Also in the Scanline renderer, I've turned on transparency rendering. Without it, alpha channel will be flat. With it, alpha channel will have the proper alphas which are coming in. Now once this is done, I went ahead and added it on top of my original footage. You can't really see this first merge, mainly because it's as a placeholder. It's very light just to add in slight color variation, and once this is done, I've added in a new merge which is adding in all of the details of the noise. Now the main thing to note about this merge is I've made sure that I'm using the overlay blend mode, which makes sure the blacks and whites are properly used. The main reason for this is when you're actually looking at this, you can see that even this red actually has some kind of specular highlights inside it. You're not losing a lot of detail, so it actually looks like there might be some wet blood. So therefore overlay is a very good blend mode to use. I can go for soft light or maybe even hard light, but they will not give me the same results. So as you can see, hard light is too harsh and soft light is too soft, so overlay gave me the best results, so I left it as it is. Next, finally, I applied a simple color correct where I wanted to make the skin look a bit better, so I've added in this color correct and added and changed a bit of gain and offset to get whatever looks best. So pretty much that's it, and I finally got this result. So let me go ahead, I'll flipbook this final result which I have and show you what we have created now. So here we now have the final output, and as you can see, the texture is sticking pretty nicely on the forehead. There is absolutely no slip that we can see, and obviously the texture doesn't look that photorealistic, mainly because it's a mock-up and I'm not the best artist out there, and I'm mainly concerned with teaching you the technique rather than the quality of the output right now. So I really hope you guys were able to understand the techniques and found this tutorial useful. Let me now go ahead and briefly summarize all that we have learned in this video. I started this tutorial by showing you exactly how to do this simple table track using both automatic and user tracking methods. So to begin with, auto tracking or user tracking always requires a camera tracker node, in which the first option or the first tab itself gives you most of the options necessary for tracking. You need to first track features, then solve for the camera. All the automatic tracking options you need are under the tracking tab, and the camera properties on the solver tab, and the lens properties in the lens tab. Once you're finished with your solve, you can go to the refine tab and try to get the solve error as low as possible. Once you have finished your entire solve, you can orient the scene by going into the scene tab and trying to change the values, or you can go ahead and constrain the points right in the viewport. Once you have finished your entire tracking and you are satisfied with the solve you have, you can either create a camera or you can create a scene. once we finished with the automatic tracking and simple user tracking, I've shown you how to go about using the tracker node within Nuke to create simple user tracks, assisted user tracks in Nuke, and how to transfer these values within the 3D camera tracker. So once you've tracked this, you transfer them here, and then you can use these values for constraining. And this will give you a much better result than just pure auto tracks. Now coming to the actual face tracking and composite itself, the first thing we started by is creating a key for the object so that we can track only the face and ignore the background. Using this key, we were able to get a camera track only on the face and then create only the camera. Using this animated camera connected to the point cloud generator, we were able to create an actual point cloud of the whole face, and then we had to go ahead and create a group for the actual point cloud. So to do this, we had to go to the viewer, go to vertex selection, select the points we wanted, and create the group, and then bake the group to an actual mesh. Once we actually obtain the mesh, because it does not have any UVs associated with it, the entire texturing had to be done using a projection camera. So the texture actually was created entirely in Nuke for this tutorial, whereas you can go ahead and use any image you want to be applied as a texture on top of it. This entire texture was then rendered out and then finally composited on top of our original footage so that it does not slip, and this is the final output. Okay, so that brings us to the end of this tracking tutorial in Nuke. In here, I have shown you how to do some basic auto tracking, user tracking, the different options that are available when using them, how to orient your scene, and finalize your track. Also, we saw how to generate some point clouds, generate mesh, project textures, and then finalize your composite. If you have any critiques, suggestions, or doubts after having watched this video, you can put them in the comments under this video and I'll get back to you as soon as possible. Also, if you find my free tutorials useful, please consider backing me up by purchasing a few of my paid tutorials, which will go a long way in helping me. So that's it for this entire tracking tutorial. I really hope you found this tutorial useful. I'll see you in another one.